Okay, so far the special segments that we have talked about are, let me refresh our memory. Mid-segments, remember, are segments connecting two midpoints of triangles. Angle bisectors, we've dealt with before. They bisect angles and triangles. Perpendicular bisectors, we've talked about them before. They go through the midpoint and are perpendicular to a side of the triangle. Another point that we've discussed was how in a triangle, those angle bisectors are all concurrent, meaning they all intersect in one point and it ended up being a very special point. Same thing with the perpendicular bisectors. They all were concurrent and intersected in one point. We called it the circumcenter, and it was also very special to us. The next segment that we're talking about is a median of a triangle. And it is a segment, look at the markings, that does what? What do you notice that's special about a median? What is it passing through? Where does it start? What do you notice? I'm hearing some great things, but I want it a little bit more organized. Andres, what do you observe? Okay, give me a word for that. If it's bisecting it, fantastic. The word I'm looking for, however, is midpoint. Remember, if it's passing through the middle of the segment, it's passing through the midpoint of the segment. Where is it starting, ladies, gentlemen? It's starting at a vertex. Okay, so a median of a triangle is a segment drawn from, I know there's a delay when I'm recording, I don't know why. There it goes. Median of a triangle is a segment drawn from the vertex, you know what, with the delay and with the amount of space I have, I'm going to type this instead. It's going to be one of those days. There we go. There we go. Okay. It's drawn from a vertex to the midpoint of the opposite side. And just like the angle bisectors and just like the perpendicular bisectors, the medians of a triangle, all three of them will be concurrent, meaning all three of them will conveniently intersect in one special point. And that special point is called the centroid of a triangle. If I had a cardboard triangle, and for whatever silly reason that I could come up with, I wanted to balance that triangle on the tip of a pencil, the centroid would be the point at which I could do that. The centroid is the center of gravity of that triangle. So as indicated in your notes, the centroid will always be inside the triangle. Kind of flash back to last week and the week before. Remember that the in-center of a triangle was also always inside the triangle, whereas the circumcenter was inside when it's acute, outside when it was obtuse, and on when the triangle was right. Okay? Just like the in-center and the circumcenter, there's something calculation interesting about the centroid. And the way that I have it in your notes is kind of confusing, and I apologize for that, but I think I also have it, yeah. In addition to what's on the screen, you'll notice that there's one extra sentence next to that where it says theorem in your notes. After what you see on the screen, you see a parenthetical statement. You might want to highlight that. That's the easiest way to think about this whole centroid property. And actually, that's still not the easiest way I could have put that. Okay, so eyes up. Let me show you what I mean by what I wrote there that I really should have written in an easier way. Let's consider another median of the triangle. It would go here, making this point, let's call it X. That point is the centroid. So X is the centroid. Get used to it. X is the centroid. What I want you to observe is that the centroid divides a median. Christian, I know it sounds weird, but I'm trying to fix it. The centroid divides the median into two parts. Do you see that there's a long part and a short part? Okay. Main thing that I want you to get out of this theorem is that the short part is half the long part. Most of the time, that's enough to get you through these centroid and median problems. Sometimes it's not enough and you do need this 2/3 bit. Okay, so this 2/3, what I want you to understand, this 2/3 is saying that the long part, well, let me put it this way. I'm trying to put this as simple terms as we can work with. The short part is half the long part. We've already got that. That means that the short part equals the whole median divided by 3. Okay, these are little tidbits that I would strongly urge you add to your notes because, and I apologize for it, I wrote it in a manner that is just even more confusing. So I'm trying to simplify it here. So whatever the median is over 3 will give you the short part. And then you know that the long part is twice as long as that, so you can kind of work through, gentlemen, work through these centroid and median problems if you know those two facts. Okay? We're still getting what we need here. Okay, a little bit more vocabulary. The last kind of special segment that we're talking about is the altitude of a triangle. And unfortunately, even though for the most part, the main thing that you need to get is that it's coming from a vertex and it's perpendicular to most of the times a side of the triangle. Hold on. The definition has to be the way that it is. Notice how the definition is phrased. It's a perpendicular segment from a vertex to the line containing the opposite side. Now that sounds a little bit weird. Let me show you why it has to be that way. First of all, let me show you an easy altitude. Okay, from this vertex going perpendicular to the opposite side, that's easy. I can go from here to there, and that's perpendicular, no problem. That segment, AX, is an altitude. It goes from a vertex perpendicular to the opposite side. However, I want you to notice that, do you see that there is no way, there it goes. Okay, do you see, eyes up please, so you see what I'm trying to point out to you. Do you see that it is impossible for me to draw a segment from B to this segment and it be perpendicular? It's impossible for me to draw a segment from B to anywhere on this segment and it be perpendicular. In order to get that perpendicular side, I have to extend this side. I have to extend this side here in order to then draw the perpendicular segment to the line containing the opposite side. Okay, so I know that the way the definition is given to us is kind of weird, but this is the situation in which that wording is necessary. I can't draw the perpendicular line from B to the opposite side. It had to be to the line containing it. Okay?
Wait, what's our break?
We have 3 weeks. All right, let's come back to these problems. In problem 1, notice what we are given, notice what we're trying to find, ladies and gentlemen. SP is 16. First of all, what I want you to observe is that based on the markings, P is our centroid. So what I want you to observe is, like I mentioned before, that centroid is dividing each of those medians into a long part and a short part. And the short part is half as long as the long part. So SP is 16. What is SP? Is it the short part, the long part, or the whole thing? SP is the long part. They are asking me for SM. Whoa. Hold on. SM is the whole thing. Now, the way that the book would have you do this involves fractions and 2/3, and it's moderately unpleasant. Okay? So, listen, so that I can give you what I hope is my easier way. In order to find SM, doesn't it make sense that I would add the short part and the long part? Well, we just identified that SP is the long part. Tell me what the short part's going to equal. 8. Okay, so 8 plus 16 is 24, if my screen ever catches up. There it is. Okay? Take a moment, work through the your turn for problem 1. Okay, based on what I am seeing and hearing, you are ready to compare your work to mine. I loved hearing you going through that thought process, taking that long part, dividing it, excuse me, gentlemen, waiting, dividing it in half to get that 4.5, and then taking that short part, adding it to the long part in order to find the whole thing. The ratio of TP to PL, it should make sense, since TP is the long part and PL is the short part. It's 2-to-1. Any questions on this screen?
No.
Okay, the next part of our notes involves simply identifying what kind of segments we're looking at. So in problem 2, parts A and B are simply asking us what kind of segments are these. And this was also, granted, we hadn't yet talked about medians and altitudes, but in the quiz where you were asked what kind of segment it was, whether it was an angle bisector or a perpendicular bisector, I was surprised by how many of you were getting them backwards. You have to look at the markings, ladies and gentlemen. So in part A, segment AC is what? A median and altitude or neither? It's a median. What you need to observe is that C is a midpoint. How about B? What is AE? A median and altitude or neither? It's an altitude. Take a moment, work through the your turn problem 2. Please, based on what I'm seeing and hearing, there's a little bit more confusion, gentlemen, than I would expect. For part A, I think overwhelmingly we get that segment AD is a median. Gentlemen, if you're not talking, if you're talking, then you're not listening. Statement B is asking us what kind of segment EG is. Notice that both segments in today's lesson start at a vertex. Neither E nor G is a vertex of the triangle. This is neither. if anything, it looks like it could be a mid-segment. Okay, but it doesn't have the markings on AG and GB, so we can't say that conclusively. Statement C is asking us about CF. Notice that it's coming from vertex C and is perpendicular to the opposite side. This is an altitude. I have one additional problem that I want to work with you on the back of our notes.